Hello and welcome to this video. My name is Martin Mwenda, one of the Kenya Airlift program GMAT trainers. And as usual, this video is part of a series through which we are sharing some of the techniques and strategies of handling the GMAT exam. And these are the same strategies that we usually share with our students as we take them through our GMAT training program. And in this video, I'll be focusing on the numerical form subtopic, which is from the number theory major topic. And this subtopic is tested in the form of fractions, decimals, as well as percentages. However, for this video, I'll focus majorly on fractions. And as usual, I'll be focusing on 3 questions and trying to highlight the best strategies and the most efficient means or approach of solving the equations and arriving at the best answer. And I'll also be focusing on data sufficiency as one of the ways through which the GMAT tests GMAT quant. Right, on to the first question. So this question, the focus of this question is on comparing or the comparisons of the magnitude of fractions. And it says that if z is equal to one of the numbers, 3/5, 5/8, or 2/3, then what is the value of z? And then we're given 2 statements. The first one being that half is less than z, which is less than 2/3. The second one being that 5/9 is less than z, which is less than 5/6. And as stated here on the screen, the best approach to solving this question or addressing what is required of you from this question is to decompose your approach into 3 steps. And the first one being is to identify the type of question. Okay, and in this case, our type of question here is it's a value question. This is because we asked what is the value. So in essence, the question requires us to find a value for the value of for the variable z. Then definition of sufficiency for any of the 2 statements to be sufficient, then it must give us a specific value. So for value questions, they must always give a specific value for whatever is being asked. And in this case, it's the value of z. So you need to get a specific value of z for a statement to be sufficient, and we're going to term that statement to be insufficient if it doesn't give us a specific value of z. And that would mean that it's giving us, say, a range. We might be getting, say, the value of z is in a range as, what is stated in the statements here. So then when you're dealing with such questions of the comparison of the magnitude of fractions, the best approach, or one of the best approaches to these questions, would be to express them as decimals. So in this case, 3/5 would be 0.6. We can do the division. 3 divided by 5, this would be 0, 30, 0.6. 5/8, this would be 5/8 would be 0.625, which can be gotten directly as 0. Is because of 48, you would get 6. Then the remainder here is 2. 20 would give us 2 because of 16. The remainder is 4. 40 would give us 5. That is 0.625. Then 2/3, definitely this is going to be 0.666, where 6 is recurring. So you can say that just from these fractions, we can tell which one is bigger than the other one, right? We can tell that 0.6 is less than 0.625, which is less than 0.66. So then we have a means of comparing the magnitudes of the 3 fractions. Then we look at the statement. The first statement uses the fractions half and 2/3 as the limits. And we know if we are to express half as a decimal, this would be 0.5 to be less than z, which is less than 0.66 recurring. So then from this statement, we can tell out of the 2 values that were given in the question stem, that is, the 3 values that were given in the question stem, that is 3 over 5, 5 over 8, and 2/3, we can tell that these two are the ones that fit within the region specified by statement 1. That 0.5 is less than z, which is less than 0.66. It's these two, 0.6 and 0.625. So then we can tell that statement 2 refers to two values, that is z. When you're looking at statement 1, it gives us the value of z to be equal to 3 over 5 or 5 over 8. And remember that for a statement to be termed as sufficient, it must give us a specific value of z. So for the reason that just because statement 1 gives us two values, then it becomes insufficient. And using the decision tree, we can cancel out choice A and choice D because the first statement is insufficient. So then moving on to the second statement, 5 over 9, if we are to express it as a decimal, this would be 9 dividing 5. This would be 0, 0. This is 5 because of 45. And you can see that 5 is going to recur. So you have 0.5555, where 5 is recurring. Then we have 5 over 6. So 6 divided by 5, this would be 0.8. So you can see you already have 0.8 being as 0.8 would definitely be a value greater than what we have for the three values that are given in the statement in the question stem, that is 0.6, 0.625, and 0.66. None of them is actually greater than 0.8 or equal to 0.8. So then it means that the three of them do satisfy the condition set by statement 2, that is 0.5 recurring is less than z, which is less than 0.8. Of course, there are other values to this. So we can see that the three values do satisfy or fall in this region. So then this statement 2 is also not sufficient, since all the three could be the values of z. And remember that you're looking for a specific value of z. So then choice B2 becomes insufficient. So at this point now, we can move ahead to combine the two statements to see if they do present any new information. So if we look at the combination of two statements, we can see that the regions that they are specifying are, we have 0.8, 0.8, we have 0.6, 0.66, we have 0.5, 0.5 recurring, and 0.5. And then we can say that the three values, that is 3 over 5, 5 over 8, and 2/3, they do fall in this region here. So statement 1 specifies the region from this point to this point. So it does include 2, that is 3 over 5 and 5 over 8. And statement 2 specifies the region from 0.55 to 0.8, which then means that it still does include all the three values, meaning that no new information is presented by the combination of the two statements. And for that reason, then the two of them together cannot be sufficient, since they do not present any new information. And the correct answer here becomes choice E. Okay, so the second statement, question, so this one states that if x multiplied by y is not equal to 0, then is the reciprocal of x over y greater than x over y. So in essence, what this question is asking is whether x over y is greater than y over x. This is the ask. Then the condition is that the product of the two variables, that is x and y, should not be equal to 0, which then means that neither of the two values can be equal to 0. Both of the two values are not 0. because you could only get the product, their product being 0 when either of them is 0 or both of them are zeros. Okay, so from that we can look at the first step, which is to define the type of the question. And this question, since it's asking us, is this value greater than this one, it's a yes or no question, which then means that our definition of sufficiency is such that a sufficient statement is one that responds to the question stem as consistently. We're looking for consistency here. Consistently yes, or consistently no. So when we get consistency, then that statement becomes sufficient. Yeah. So if one of the statement gives us at times yes and others no, then it becomes inconsistent, and for that reason it's insufficient. That's our definition of sufficiency for yes or no questions. And in this case, if we are to find that x over y is greater than y over x all the time, then that means then we are responding to the question stem as consistently yes. And in that case, then that statement will be sufficient. And if you are to get that you are responding to this question, that x over y is greater than y over x, you are responding to that as no and consistently so, then that statement becomes sufficient too. But then if there are situations where you're saying that x over y is greater than y over x, and others where you're saying x over y is less than y over x, then it means that there isn't consistency. And for that reason, then that particular statement will become insufficient.
You're watching Success with Bob Mwiti Show, presented to you by Appstech America. Appstech America is a consulting company that helps immigrants find amazing higher education and job opportunities in the tech industry in the United States. You can find our programs by going to www.appstechamerica.com. Appstech America, we wake you up to the unlimited potential within you.
Looking at the first statement, it says that x is greater than y, meaning then that if, say, we were to look at all the positive values, and remember that you're only not looking at 0, so all the other values are suitable for consideration in this case. So if we were to look, say, we look at all the positive values, that is from 1 all the way to positive infinity, and we choose values of x and y such that x is always greater than y, we would say you took a value that like x to be equal to 4 and y to be equal to 3. Yeah, this one does satisfy the condition set in statement 1 that x is greater than y, 4 is greater than 3. So then we substitute it to this question here, or this expression here that defines what the question stem requires of us. So we have 4 over 3. We want to see 4 over 3. Is it greater than 3 over 4? The response to this is yes. Yeah. So when we have when we've chosen all values, or both values to be positive, then we can see that we are responding yes. So we want to see, is there any other situation where we would choose values of x and y and respond to these question stem as no? Say we take values of x, both of them to be from -1 all the way to -infinity. Say we now take value of x to be -3 and y to be -4. So in this case, you can still see that x is actually greater than y, -3 is greater than -4. So then we substitute it into this expression such that we have x is -3 over -4. We want to see if this is greater than -4 over -3. And our response to this question is no, because 3 over 4 is not greater than 4 over 3. Yeah, 3/4 is actually less than 4/3. Yeah. So then since there isn't consistency, we can see that at times you're responding yes and others you're responding no to the question stem, then the first statement becomes insufficient. And in our decision tree, we cancel out choice A and choice D. Then moving on to the second statement, it states that the product of X and Y is greater than 0. This means that X and Y can be can either be all positive or all negative. This is the only situation where the product would always yield a value that is greater than 0 or a value that that is always positive. This is the only case where we would have this product being greater than 0. And remember that from what we've done in the first statement, we've actually considered two situations where both values X and Y are positive and both values of X and Y are negative, which is still what we have in statement 2. So then we can definitely tell that this statement 2 is not sufficient, since it still gives us, the conditions that are set, the conditions that we chose in evaluating the first statement. So then choice B2 is not our correct answer, because the second statement is not sufficient. And if we are to combine the two statements, notice that they do not present any new information, because there isn't any way we can separate what we have from statement 2 from what we have in statement 1. Yeah, and also you need to be aware that for statement 1, there are other values that we could have actually considered, say in the case where X was positive and Y would be negative. However, we didn't go to that extent just because we got what we were looking for, that we wanted to see is there consistency, and we noted that there are two different situations, one where we are responding yes and one where we are responding no. And just because of that, even without testing the other possibilities, we can tell that this statement is not sufficient because there isn't consistency, right? And this follows from our definition of sufficiency, that a statement will only be sufficient when it actually responds to the question stem consistently. Yeah, right. So on to the final question. This is a level 700 question, and the reason for that is just because it requires a higher level of critical reasoning, and so it would be expected that not a majority of the students will be able to solve it. So it states that if 17 factorial divided by 4 raised to power x is an integer, is x a prime number? So this is a combination of other topics as well as numerical forms. It's a combination of counting methods, in this case where you're looking at factorials, and it's also a combination. It also does include exponent, in this case where you have 4 raised to power x, and number types where you're looking at prime numbers. So by looking at what we have in the question stem, we can tell that the type of this question is a yes or no question, because we asked whether this value of x is a prime number. So the only way we would respond to this question stem is as either yes or as no. So then our definition of sufficiency is such that sufficient statement is one that responds to the question stem as consistently yes or consistently no. So we have our definition of sufficiency, and in this case, we would respond to the question stem as consistently yes if all the values that we would get of x were do satisfy the condition of being a prime number, and these values of x are going to be limited by the statement. Say now, if you're to find the value of x that would yield an integer here, and say there are several values. Now we look at the limit or the conditions set in the statement. If the first statement specifies several values, and these values, all of them are actually prime numbers, then we would respond to the question stem as consistently yes. But then if it would yield situations where both of some of them would be prime numbers and others will not be prime numbers, then the statement becomes insufficient. So let's begin. So the best approach to this would be to begin by identifying the possible values of x. So in this case, we have 17 factorial divided by 4x, 4 raised to power x. And we want to see what values of x would make this division yield an integer, which then means that we don't want to be having a remainder. And we would only get that if there are multiples of the denominator, we are getting multiples or factors of the denominator in the numerator. So in this case, we know that 17 factorial is going to have certain values or products, I mean, values that are multiplied in this case, because 17 factorial would be 17 times 16 times 15 times 14, all the way to times 1. Yeah. So in this case, we know from this factorial, there are certain values that are actually divisible by 4. And some of them would be, we would have 16, we would have 12, we would have 8, and we would have 4. These 4 values are actually divisible by 4. So if these values are present in this, then that's the only case where we would, this division would yield an integer. Yeah. So in the case if we would only if x was, say, the value 1, if x was 1, you definitely have 4 divided by 4. Yeah, that would actually yield an integer. If x was 2, we would have 4 times 4 as the denominator. So then we would cancel 4 here and would also cancel it here. So you can notice that if you are to express all these the 4 values as factors of 4, we would have 16 is the same as 4 times 4, 12 is the same as 4 times 3, 8 is the same as 4 times 2, and 4 is same as 4 times 1. Yeah, so then you can see how many factors of 4 we have: 1, 2, 3, 4, 5. So we can have 17 factorial divided by 4x, and x can take the values 1, 2, 3, 4, and 5. Because if it took 1, we would have actually have 17 factorial divided by 4, which would actually yield an integer, as we've seen by cancelling out 4 and 4. If we had 2, we would actually get 17 factorial divided by 4 squared. 4 squared is 16, which would actually work. If we had 3, it's the same case, yeah, because we can actually get factors of 4. Yeah. So then we have 5 possible values of x. Now we look to the statements to see if there is any limits or limitations that would yield a prime number. Yeah, and for us to get a prime number, we would only need a statement that eliminates these 2. We want to see statements that are going to eliminate the values 1 and 4, so that you're left with only 2, 3, and 5. They are the prime numbers here. So looking at the first statement, it says that 30 divided by x is an integer. So if we are to divide 30 by 1, you would actually get 30, an integer. By 2, you'd get 15, an integer. By 3, you'd get 15, an integer. By 4, 4 wouldn't work. It gives us 7.5, which is actually not an integer. 5 would yield 6, which is an integer. So the first statement allows us to pick the values 1, 2, 3, and 5, but 1 is not among the prime numbers. So then we can see that if we were to respond to the question same for the 4 values here, if we pick the value 1, we would respond to the question stem as no. But if we picked the other 3, we would respond to the question stem as Yes. So you can see there isn't consistency. There are times when you are responding to the questions, they must yes for the 3 values. And when you are responding to the questions, they must no for this value. So then statement 1 is insufficient, and choice A and D cannot be our answers. Then we look at the second statement, that is X is greater than 2. Yeah. So if we are to choose any of the 5 values and we choose one that is actually greater than 2, we would only be picking 3, 4, and 5. That is 3, 4, and 5. And now we ask, are these 3 values prime numbers? The first one is a prime number, the second one is not, and the third one is. So still we can see there isn't consistency, because at this, when we choose 3 and 5, they are prime numbers, but when we choose 4, it's not a prime number. So which means then we are responding to the questions sometimes yes and sometimes no. So then statement 2 is not sufficient, and choice B cannot be our answer. So then now at this point, we can combine the 2 statements, and combining the 2 statements yields. So the first statement only picks 1, 2, 3, and 5. The second statement picks 3, 4, and 5. So if we are to combine the 2 statements, the only values that do satisfy the 2 statements, the only values that do satisfy the condition set by statement 1 and the condition set by statement 2 would be 3 and 5. Yeah. So combination, statement 1 and statement 2 yields 3 and 5. So how do we respond to the question stem for this? The 2 values prime numbers? Yes. So then we can see there is a consistent response to the question stem, which then means that these 2 statements together, they are sufficient, and our correct answer becomes choice C. Yeah. Thank you. And that has been the video for this week. I hope it's been helpful.
You've been watching Success with Bob Mwiti Show, brought to you by Upstack America. Come back next time to hear more steps and missteps that I took on the path to becoming a successful immigrant in USA. Be sure to subscribe to my YouTube channel and also follow me on Facebook, Instagram, Twitter, and LinkedIn.